Hello, everybody. So today we're going to be discussing complex numbers. Complex numbers are used in a lot of different areas, such as electrical engineering, cellular technology. I know everybody has a cell phone. Studying brain waves, many other places in the real world. But we're going to be focusing on just doing basic operations with them, and also being able to solve quadratics that have no real solution. So a complex number just implies that it has an imaginary unit. So every time we came to a problem where we had to take the square root of a negative number, we would always just say there's no real solution. So now that we know what an imaginary unit is, we would be able to do that. And that's supposed to be an I. It looks like an upside down exclamation point, but we can think of it denoted as an I. That's what that should look like. So I is equal to the square root of -1. So that's going to be our big fact here throughout this lesson. So whenever we have a square root of a negative number, we're going to be using that I. All right, so here's kind of your rule. So whenever you have a negative underneath the square root, all we have to remember is that we should put an I out in front. So let's take a look at this example here, the square root of -3. Well, that's the I radical 3. We just pull out the negative. So the square root of -4, we can do the same thing. I square root of 4. But hopefully we see that the square root of 4 is a perfect square. So we want to put it, the square root of 4 is 2. So if we can actually take the square root of the number, we should put the I after that. If we have a radical, the I should go in front of it. All right, so there is something else that we should be paying attention to. This might pop up on the ACT for you. They like to throw these I questions in. So there's a pattern to how I grows. So if I is the square root of -1, what do you guys think I squared is? Well, let's square I, right? I is the square root of -1. If we square that, well, the square root of square inverse operation, so we end up with a -1. So I cubed. So I cubed is just I squared times I, right? That makes 3 i's. Well, we know I squared is -1, and we know that I, let's put an I there, so -1 times I is equal to, running out of room here, -I. Give me 1 second. Let me move these guys out of the way here. Okay. All right. So let's try if I can rewrite this a little bit nicer looking. So -1 times I is -I. So I to the 4th. Well, I to the 4th we could look at as being, when I think of I to the 4th, I think it's I squared times I squared. We already found I squared to be -1, so we're just going to replace those with -1 times -1. So that equals 1. All right, so let's do I to the 5th. So I to the 5th would be I to the 4th, which is a 1, times I. Well, that's just I. Yes. And now I to the 6th. Well, I to the 6th would be I to the 5th, which is an I, times another I. So I times I squared, would be a -1. So notice we're starting to repeat this pattern here. So if we did I to the 7th, we would end up with a -I, like we did with I cubed. So there's our pattern here. We got, it goes, you got your I, let me get my highlighter out. So I, -1, -I, 1, and then it repeats over and over again. All right. So if you wanted to actually find something like I to the 23rd, you could sit here and do this 23 times, or you can divide it by 4 and see what our remainder is. So if we divide 23 by 4, that'll give us a remainder of 3, right? So our remainder of 3 means it would be an I cubed. So we would say our solution is, so this would equal -I, because we're using the I cubed. So if our remainder was 4, we would use, if we had a remainder of 4, we would use the 1 as our answer. If we had a remainder of 2, we would use, remainder of 4, that would be a remainder of 0. If we had a remainder of 4, it would be a 1. If we had a remainder of 2, we would have a negative 1. If we had a remainder of 1, it would just be I. So let's write that out. So I'm getting distracted. There's a lot of noise in here. So if your remainder equals 1, your answer would be an I. If you get a remainder of 2, your answer would be a negative 1. If you had a remainder of 3, your answer would be a negative I. And then if you had a remainder of 0, which means it divides in evenly, you would have a solution of 1. There we go. All right, so a complex number is actually 2 parts. It has a real part and an imaginary part. And we always write them as A plus BI. So the real part should always go first, and the imaginary part should always go second. We don't want to write them like 5i minus 2. That is not correct. We want to write it as negative 2 plus 5i. That is the standard form. So if we want to add or subtract, they're pretty simple. We just combine like terms. So let's take a look here. So here we've got negative 1 plus 3. That would be a 2, right? Then we have 2i plus 3i. That would be a 5i, and we are done. So now let's go to the next example here. We're going to combine all our i's. So we got to make sure we distribute our negative sign through. So we have 2i minus I gives us 1i. And then I'm going to do 1i plus negative 3i will give me a negative 2i. Now let's combine our other numbers. So we got a negative 3 plus 2. So negative 3 plus 2 is negative 1. So are we done? No, we are not, because we need to write it in standard form. So we have negative 1 minus 2i. All right, so our last one, I'm going to do this one. Again, we got to distribute that negative sign through. So you have 2 minus 3, that's negative 1. And then negative 3i minus negative 7i. The two negatives make a plus, so really that's negative 3i plus 7i, which would give us a positive 4i. That would be our solution. All right, so multiplying. So if we're going to multiply, we're just going to treat the i's like variables. And then we're going to have to adjust what we have as our solution. We'll talk about that here in just a minute. So I'm going to distribute my negative I through to both terms here. So that's going to give me negative 3i. And then negative I times positive I would be negative I squared. So when we think back to our previous slide here, what do we know I squared equals? What does I squared equal? Negative 1. And for the most part, we're not going to worry about anything above I squared when we practice these. So whenever we come across an I squared, we need to replace it with a negative 1. So that's exactly what I'm going to do. I'm going to go negative 3i minus negative 1. And now I need to rewrite it. Two negatives make a positive. I'm going to put my real part first. Minus 3i. Now we have it standard form. So now if we want to multiply two binomials, we can do it using the box method or FOIL. Totally up to you, however you want to do it. So I'm just going to use FOIL. I'm going to do first times first. That's going to give me a negative 12. And then I'm going to go outer. It's going to give me a negative 4i. Then I'm going to go inner. It's going to give me a negative 18i. And then I'm going to go last times last. That's going to give me negative 6i squared. So now notice we have an I squared there. So what we're going to have to do with that I squared is replace it with a negative 1. So I'm going to combine these two terms because we got like terms there. So now I've got negative 12 minus 22i. And now I have minus 6 times negative 1. So I'm going to replace that I squared with a negative 1. So that's really going to become a plus 6 right there. We've got negative 12 minus 22i plus 6. So now I can combine that negative 12 from the positive 6. So we got negative 6 minus 22i, and that would be our solution. So not too bad. So the main thing you gotta remember is when you're multiplying, if you end up with an I squared, you need to replace it with a negative 1. And if you end up with an I cubed for some reason, you replace it with a negative I, using those patterns that we talked about from the previous slide. So we can also graph numbers, complex numbers, and it's pretty simple. Your x-axis, what you think of as your x-axis, is what we call the real axis, and what we think of as the y-axis, we're going to consider the imaginary axis. So let's go through and see what we got here. So let's color code them. So -2 plus 5i. The first number tells you to go left or right, and then the imaginary number, the second number, tells you to go up or down. So this one's telling me to go back 2, up 5. So there, yeah, that's all we got to do. And then, so let's take a look at the next one, 2 plus 2i. So that means the first number tells us to go right 2, and the second number tells us to go up 2. That's all there is to it. 4 minus 3i, so that means you go right 4, down 3. And we're done. So I guess I should underline that. And last one here, which is purple. So that's telling us to go back 4 and then down 3. 1, 2, 3. So that's all there is to plotting. The first number tells you to go left or right, the real number. And the second number, which is our imaginary number, tells us to go up or down. All right, so the absolute value of a complex number. We have a formula for that. And so we're just going to use that formula. And we'll talk about what this actually means. So, because you guys should have all seen this before in some form. So a squared plus b squared. So that'd be -2 squared plus 5 squared. So that's going to give us what? 4 plus 25. So it's going to be the square root of 29. And if we can simplify it, if there's a perfect square in there, we should pull it out. But this one doesn't. All right, so let's do the next one. Then we'll talk about where this is coming from. So we got the square root of 5 squared plus -3 squared. So that's going to give us 25 plus 9. So when we add those together, we end up with the square root of 34. So 34 does not have any perfect squares of it, so that's as far as we can go there. All right, so now this is really just the Pythagorean theorem, because what we were doing here is finding the distance from 0, from the origin. So if we think about this graph here, we've got it's -2 plus 5. So I go back 2 and I go up 1, 2, 3, 4, 5. There's our point. So what we're doing here is we're finding this distance. And the way we're finding it is we're really just drawing a right triangle here. And we're using a squared plus b squared equals c squared. So really this is just a modification of the Pythagorean theorem. All right, we made it through.